Hey Opties! Today we're talking about linear word problems. We're going to be looking at word problems in standard form, slope-intercept form, and just some percentage problems which are also linear. Let's take a look at our forms for standard form and slope-intercept. So our standard form linear, that is an equation, and it's just one way to write a linear function. Standard form reads ax plus by equals c. Below is the outline for each of these variables. A is the rate for x is the quantity, or a quantity, that would go with whatever that rate is for x, which would be a. B is the rate for y is the quantity that goes with the rate b. And c is some constant. And often c would be like a total number of something. Slope-intercept form, y equals mx plus b. The y is the dependent variable, so it changes based on whatever x is. M is the rate of y per x. Remember, slope is the change in y over the change in x, so m is slope. X is the independent variable, and b is the initial or startup value. Let's take a look at a standard form example. It'll make more sense what these ax, by, and c mean when we see an actual example. So it says, standard form example, Tuckett is having a concert selling children tickets for $5 and adult tickets for $10. There were 215 children tickets and 523 adult tickets purchased. How much money was received from ticket purchases? Okay, so we've got several different pieces of information. So we set a variable c for the number of children tickets, c for children, and we said let a be the number of adult tickets, so a for adult. So $5, that is going to be a. That is the rate for how many children tickets. So c is like x, and the rate is $5. A is the number of adult tickets. It's like our y. And b is the amount of money per adult ticket, which is $10. 215 children tickets. So that actually gives us the number of children tickets. So instead of having c, we can actually substitute that number. And similarly, we can substitute 523 for a. So here is our equation. $5 times c plus $10 times a. Now that would equal some big old c here, a constant, and that's what we're trying to find. So we substitute our number of children tickets and number of adult tickets, and we multiply and we add, and we get 6,305. So that's how much money was made at this concert. So that is going to be our C. Let's take a look at our slope-intercept form example. R&I Cookies charges an upfront order fee of $50 and hourly fee of $5 per hour for services of royal icing cookies. That's pretty cheap, man. I mean, these suckers go for like $1.50 a piece. R&I is the place to go. Anywho, how much money would an order that takes 4 hours cost? Now, both of these examples, you could probably just figure it out without actually writing an equation in these forms, but they are set up in such a way that using these specific type of linear formulas are helpful. So that's why we're doing this. You could just say, oh, well, you got to start with $50 in 4 hours. That's just going to be 5 times 4, so 50 and 20, $70, right? Well, that's exactly what we're doing here. We're just writing a little bit more organized with our equation. So we said let h equal the number of hours. So that's actually going to be like our x. And let d equal the number of dollars. That's going to be our y. Now B is the startup. How much do you pay regardless of how many hours are worked? That's going to be $50. And our slope, or our rate for our X, is going to be $5 because that's $5 per hour. And so we have the number of hours. So this is like our 5x plus 50, or mx plus b. And the y is what we're finding, which is going to end up being 70 here. So 5 times 4, so $5 per 4 hours, plus 50 to start up is 20 plus 50, which is 70. Now let's take a look at some percentages. We're also going to write these as equations to solve. However, there are several different ways to solve these types of problems. I personally find it helpful to use an equation. Some people like to use is over of equals percent over 100, which is like a proportion type of setup. To me, writing an equation is the most simplest for myself, but everyone's different. So if you have a way that works, use that if you'd like. Let's take a look at the first one. What percent is 50 of 10? So what percent can act like our X here? Is like our equal sign. 50 just stays as 50. Of is like a multiplication symbol. And 10 just stays as 10. So X equals 50 times 10. So 50 times 10 is 500. So X is supposed to be percent. So X is 500. So 50 is 500% of 10. Well, think about it. How many 10s are in a 50? Well, 5 of them. So if you're going the opposite direction, it's going to be 10 is 100% of 10, right? So if you get 5 of them, that's 500%. So that's one way you could even think about it. Just kind of reason through it in your head. Our next one says 15 is 25% of what number? 15 is like an equal sign. 25% can be rewritten as 25 hundredths as a decimal, 0.25. Of is multiply, and what number is our variable X? You can use whatever kind of letter you want, but typically we use X, right? So that rewrites as 15 equals 25 hundredths X, 0.25 times X. So if you want to solve this, you can divide both sides by 0.25. Now, this is the same thing as 1/4, right? So dividing by 1/4, it's the same thing as multiplying by 4. So that's what is written here. So 4 times 15 equals 4 times 1/4 X. So those will simplify to 1. And you get 60 is equal to X. So 15, so we're rewriting it to address the original question, not just putting our variable equals the number. So 15 is 25% of 60. Just think about it, 25% is a fourth. All you really had to do is 60 divided by 4. That's one way you could have done it. But that would be saying you actually already know the answer is 60. So how do you rework that? 15 times 4. So again, there are different ways you can work this. Now let's do some tip percentages. Not that what we just did were really any different, but we're putting it in a context of a tip. So everyone needs to know how to do this, right? You at least need to know how to type it in your calculator if nothing else. But if you can do it in your head pretty quick, then you don't have to whip out your phone and type it in the calculator. So it's good to know, and it's also good to be able to calculate percentages in your head for when you're grocery shopping, if you're on a budget, which everyone totally should be, right? So let's take a look at this one. You get a bill of $21.03 at a restaurant and want to leave a 15% tip. What is your total amount spent? So the way that I think is the easiest is to always go off of what 10% is, if you're doing this in your head. So 10% of any number is like dividing that number by 10, because 10% is the same thing as 0.1 or 1/10. So if you divide a number by 10, you're moving the decimal place one place to the left because you're taking out a 10. You're taking out a whole entire place value. So that's what you can do in your head. So 10% of 2103, or $21.03, is moving this decimal one place to the left, and that's how you've gotten your $2.103. We kind of got to round that, right? Because we're talking about money. It only has 2 decimal places. So it's going to be $2.10. Now we have to deal with the 5% because we're doing 15%. So essentially we're doing 10% and then 5% and then combining those two. So 5% of $21.03, well, that's just half of whatever your 10% is. So see how we're banking it off of the 10%? We're still working with that since it's super easy to do 10%. And 5 is half of 10, right? So you can do 5% as half of 10%. So I just looked at whatever my 10% was, which was $2.10, and then took half of it, which is $1.05. So that's pretty simple. And if you want to find the total, 15%, just take those two percentages and add them together. So 15% of $21.03 is 10% plus 5% of your original amount, and that's going to be $2.10, which was the 10%, plus $1.05, which is your 5%, and that equals $3.15. So your total amount of spent would be $21.03 plus $3.15, right? So 21, 22, 23, 24, $24.38. So that's your total. A quick point to ponder here. Like I've already said, a good strategy to use for tips is to start with finding 10% by moving the decimal place 1 to the left. And again, that's because you're dividing by 10, because 10% is the same thing as 1/10. If you multiply by 1/10, then you're really just dividing by 10 and taking out a whole entire place value. All right, that's it for linear word problems. See y'all next time.